In today's lesson, we are going to study Pascal's triangle. But before we get into it, there's something I want to share with you. I'm reading this particular book, which is teaching me how to think mathematically. Bhuku racho rinonzi How to Solve It, a New Aspect of Mathematical Method, which was written by Poyler. From this book, actually the preface of this book, there's something I learned I want to share with you. So before I get to it, let me just read what I have highlighted there. I took that from the preface of the book, and the book took it from a certain academic paper which was published in the 20th century. The quote reads, "Mathematics has the dubious honor of being the least popular subject in the curriculum. Future teachers pass through the elementary schools learning to detest mathematics. They return to the elementary school to teach a new generation to detest it." Saka, even though this was produced from an academic paper, it's common knowledge kuti mathematics ndo subject rinonyanya kufoirwa, riri zvakare subject rinonyanya kusafarirwa nevanhu. But what this academic paper claims, it says kusafarirwa kunoitwa masvomu mathematics. It's not necessarily because of how difficult mathematics is. Kusafarirwa kunoitwa mathematics, it is because it is a taught behavior, a taught character. So teachers, and they have themselves been taught to detest mathematics. Then when they become teachers, they cycle back to teach the next generation or the new generation to detest it. So before you are able to pass mathematics, you have to enjoy it. And before you are able to enjoy mathematics, you have to love it. So the word of the day is find ways of loving mathematics. And if you want further elaboration on this, you can tell in the comments and we can have a discussion around it. Saka zvatiri kuda kudzidza nhasi, this is one of the topics which is enjoyable in mathematics because it gives you like credit. It gives you wit. It gives you enough reason to say that you are no longer in ordinary level mathematics. Saka, to lay out today's topic, we are going to start with something very basic, something which we learned maybe potentially in Form 1 or Form 2. Ngatiti Tapiwa 2 plus x squared, like that. So that is what we are given, 2 plus x squared. How are we going to solve that? Saka chekutanga tinoziva kuti in expanding this expression, tinotanga tanyora chi mabrackets ari 2 like this, 2 plus x, bracket ra 2 plus x, multiplying bracket ra 2 plus x, like this. Then we know that the general rule inoti each term in the first bracket should multiply the second bracket, meaning 2 uno uyanfunga ku multiply that bracket, twadati plus x uyo multiply vutichi that bracket. Then we do the multiplication. 2 times 24, 2 times x, that's plus 2x, 20 plus x times 22x, plus x times x, the x squared, like that. So then this is equal to 4 plus 4x plus x squared, like this. Saka izo ndo zvatiri kuwana. This will be our final answer. So even though you did not notice it pamakaintroducwa to expansion of algebraic expressions, you probably did not notice that your power at most was only to the power 3. Zvekutoti when we talk about functions tiri ku ordinary level, ma functions edu we deal with linear functions, ndo akanyanya kuwanda. Then topinda pama quadratic functions, anditi. Then kana taku section B of paper 2 ndo kunogona kungouyawo a cubic function, so zvatoperera ipapo in most cases. Saka For linear functions, the highest order power of x ndi 1. For quadratic ingere x squared, and for cubic ndi x cubed. Zvatiri kuzama kutsanangura ndezvekuti the power yataidhila nayo in ordinary level mathematics, that is form 1 to form 4, was in most cases not greater than 3. But we know that in the real world, and kana chitaura pamusoro pe ndingati chi what is established in real life, we know kuti those numbers cannot necessarily be that small. Saka what advanced level mathematics does is it takes you to greater powers. Patakutanga kutaura pamusoro pe to the power 4, to the power 5, 6, 10, and so forth. So we have to devise new methodologies which are applicable, which we can use in solving algebraic expressions which are raised to higher powers. Because take for instance, tikatora iyoi 2 plus x tikaiti to the power 8. Mukada kuisolva nenzira iyi 2 plus x times 2 plus x times 2 plus x, munogona kutoneta muchiri kungonyora like muchiri kuita breakdown or expand from the 8th power muchinyora each individual expression. Izvozvo zvinogona kutokunetetisai before you start the calculation. So we need to devise new methodologies. We have done that. And where did we do that? We did so per binomial theorem, where pataitichi n choose, actually before we write it down, a plus b to the n is equal to n choose 0, a to the n minus 0 multiplying b to the 0 plus n choose 1, a to the n minus 1 multiplying b to the 1 plus and so forth. Saka the binomial theorem is usable kana takudhila nema higher powers, and we should know the limitations of the binomial theorem, and my limitations acho ndeapi. Just to summarize, anenge ari pana n panapa. N anofanirwa kuva positive over zvakare a whole number. Saka kana n akava negative, the binomial theorem cannot be used. Kana n akava fractional kana kuti decimal, the binomial theorem cannot be used. Then we also learned what is called the universal expansion theorem. Saka for the universal expansion theorem, what we learned was if it is 1 plus x to the n, this then is going to be equal to 1 plus nx over 1 factorial plus n minus 1 x squared over 2 factorial, and so forth. And what are the limitations, Apo? The limitations are this should always be 1, but any edui can be anything, fractional, negative, and stuff. So where the binomial theorem fails, we can employ the universal expansion theorem. But in today's lesson now, takuda kuintroduce a third method which is applicable in expanding algebraic expressions, and that third method ndiyo inonzi chi Pascal's triangle. So as you can already tell, there should be some person called Pascal somewhere in history who proposed this triangle, and it is named after him. So Pascal's triangle, this is an arrangement of numbers that allows us to quickly work out the coefficients of terms when you expand expressions of the form x plus y to the n. Saka, this is an arrangement. Saka, we can say it's an arrangement. Kana kuti tinogona kuti it's an array of the coefficients of expressions of the form x plus y to the n. Saka ma coefficients. So maybe we have to remind each other kuti chinombonzi coefficient chi. So let us go back here. Tiri panapa. So when we introduce the Pascal's triangle, tatangira from a very basic algebraic expression, then we did what we did. Kana chitaura pamusoro pema coefficients, hama dzangu. Chinonzi coefficient, this is a number, and which is multiplying a variable. Saka coefficient panapa ya x ndi 4. Mapaona? Coefficient ya x squared ndi 1 asi papa. And we can argue with coefficient ya x to the power 0 ndi 4. Saka coefficient simply put in number iri kumultiplier x, y, z, number iri kumultiplier unknown, number iri kumultiplier variable. That is what a coefficient is. So when we talk about the Pascal's triangle, Pascal, this mathematician, and found a way of, discovered a relationship between the coefficients of different expressions in x plus y to the n. Then she formulated a triangle which is then applicable in solving, in most cases, higher order algebraic expressions. Saka zvakakosha kuziva kuti coefficient chi, and zvakakosha zvakare kunyora the definition. So when we talk about a coefficient, tikutaura pamusoro pe a number multiplying an unknown, which in most circles is called a variable. And if you wish to have examples, 2x, 2 is the coefficient of x. Like this. So this is what we are getting. And ta define, kana kuti tangoita tanyora what a Pascal's triangle is, and panapa taku define what a coefficient is. What we now want to work on is takuda kuinyora pasi Pascal's triangle yacho. And totanga tambodzidza kuti inenge yakamboita sei. Then tozoiapply kuti no apply was say. So it's fascinating, it's beautiful. Okay. So tichida kunyora pasi Pascal's triangle. Pascal's triangle yakadai, so itori triangle actually. Tinotanga tanyora 1 like that. Then tanyora 1, kuno kuto tanyora 1 na 1 say is. Maona, mruka unaka triangle kari kufomewa. Then kuno kutonyora 1. Tuatati 1 plus 1 tuwana 2. Tuenyora pakati. Kukupesira tonyora 1. Tonyora 1 kunoku. Toti 1 plus 2 ndi 3. 2 plus 1 ndi 3. Kunoku. Tonyora 1. Tonyora 1 kunoku. 1 plus 3 ndi 4. 3 plus 3 ndi 6. 3 plus 1 ndi 4. Tuatadaiso. Tonyora futi 1 kunoku. 1 plus 4 ndi 5. 4 plus 6 ndi 10. 6 plus 4 ndi 10. 4 plus 1 ndi 5. And lastly 1. Saka I can task you kuti munyore ya 6, ya 7, ya 8, kusvikira pane ya 10. Kuti muteste kuti mabata iri relationship yacho. So what happens is kumcheto kunoku kunenge kuine ma 1. But you just have to add ma number anenge akatekedzana kuti akupe number iri pasi like this. Sapana patatu 1 plus 1 tikawana 2. We can actually panapa tikato 1 plus 3 tikawana 4. Apo tikati 6 plus 4 tikawana 10. Ndangopika some few examples to show you how it works. So that is the Pascal's triangle. But remember, those are coefficients. Those are coefficients. Okay. Sakatiri panapa manje. Constructing the Pascal's triangle. How do you construct the Pascal's triangle? To construct Pascal's triangle, we start by writing a 1, as we did. In the row below, we write 2 1s either side, as we did. For the third row, we add the 2 1s in the second row to give 2, and write this in between them on the row below. The start and ending numbers of a row are always 1 cannot always equal to 1. So taisa pasi. We continue this way, adding 2 numbers to find the number in the row below it until we have written out as many rows as we would like. So that is how it's done. My task is please rambai muchikontinya kusvikira pana 10 kuti muone kuti mamaster here. Maybe just as a courtesy call regai ndingowedzera ya 6 toisa 1 kunoko. 1 plus 5 ndi 6, 5 plus 10 ndi 15, 10 plus 10 ndi 20, 10 plus 5 ndi 15, 5 plus 1 ndi 6 topedzera kuno kuna 1 like that. Saka you can add ya 7, ya 8, ya 9 neya 10. Okay, so izo zvinomborevei? That is now the question. Kuti understand kuti zvinorevei munofanirwa kudai so. Tikauya pana 1 ari pekutanga apa anenge achirepresenta x plus y to the power 0, and which of course we know that it's going to be equal to 1. So it might not make sense apa, but don't worry. Then pana 1 1 panapa ma coefficients are x plus y to the power 1. Pana 1 to 1 anenge ma coefficients are x plus y squared. Pana 1 3 3 1 ma coefficients are x plus y cubed. Pana 1 4 6 4 1 x plus y to the 4. 1 5 10 10 5 1 x plus y to the 5. 1 6 15 20 15 6 1 x plus y to the 6. Saka kana muri vanhu kana makasika kuonera muchaona kuti the second number ndo inotiudza the power. Like the second number e1 ndo yatiudza kuti power pana panenge ari to the power 1, ignoring the first one. The second number 2 ino ndo yatiudza kuti panapa inenge iri squared. The second number 3 yatiudza kuti cubed. 4 ikatiudza kuti to the 4. 5 ikatiudza kuti to the power 5, and 6 ikatiudza kuti to the 6, like that. Saka maona iri correlation iripo. That is very important. So mufanira kutanga magona kuconstructa Pascal's triangle yacho. From that mozoziva kuti each row iri kurepresenta chii. So tikada kudzokorodza izvi tinenge tichiti kunoku tiri kuti 1 1 1 1 2 1 1 3 3 1 totati 1 4 6 4 1, and totangira pane h2 inoi inenge iri x plus y to the power 1, iyo vaita x plus y squared, iyo yaita x plus y cubed, iyo yaita x plus y to the 4. But remember kuti aya esi ma coefficients kureva kuti manumber anenge achimultiplier they are known. Saka bear with me, teverai the lesson as it progresses so that you can eventually see kuti tiri kumbozvifambisa sei. Manzwisisa? Okay. Saka that's the expansion part, and we now want to apply kuti zvinomboitwa sei. Okay. Saka before we get into this example, toda kutanga tambodzokera kune our initial example, 2 plus x squared. Saka toda kutora 2 plus x squared and let me use something you can see. Saka 2 plus x squared ndo yatoda kudhila nayo. Pataicalculator kuyatipa answer yakamira sei. Answer yatipa 4 plus 4x plus x squared. Anditika 4 plus 4x plus x squared. Let us box this because that is the same answer yatoda kuwana after to apply Pascal's triangle. Okay. Saka zvatiri kuda kuita panapa ndezvekuti tese tinoziva the isomorphy, maybe it's a big word. Tese tinoziva the interchangeability inowanikwa in multiplication and addition. Kureva kuti 2 plus x squared tinogona kuinyora iri x plus 2 squared. Saka toda kudhila na x plus 2 squared. Saka kana iri x plus 2 squared kudai so, tiri kuona kuti ina squared, kureva kuti part yatinoda kushandisa ndeishi. Mukuzona macoefficients atinge tichishandisa ndi 1 to 1 like that. Saka tinofanira kutanga tanyora what is called a general statement. General statement yedu inenge yakadai so. Let us say kuti panapa instead tina x plus y squared. Mukuzona, this is going to be equal to, our first coefficient ndi 1. Saka tichanyora 1 panapa. Andika totora x which is the first term inside our binomial. Kuti binomial zongoreva in expression, algebraic expression with 2 terms. Saka inside our bracket, our first term ndi x, tonyora x panapa. Totora power e sezvairi. Mukuzona, tovatatichi squared. Saka tukutora the highest power, totora ye tovataisa ku lowest power like that. Saka tinotanga tanyora the coefficient yata extractor from Pascal's triangle. Then tovatatora the first term to erase to the squared, which is the highest power yatinayo. Totora the next term to isa to 0. Tovatati plus. Tonyora the second coefficient which is 2. X unoyu manje akuchireduce by 1 degree. Kurauti angambori x squared x to the power 1. Y unoyu increase by 1 degree, angambori to the 0 ava to the 1 like that. Ndosunoitwa. Saka x atanga ari maxed out, aine the highest order, the highest power. Power yo ichatanga ku decrease by 1 degree. Y atanga ane 0 achatanga ku increase by 1 degree. Kusvikira x angambori maxed out ava 0, y angambori 0 ava maxed out. Saka tadaiso tichati plus. Totora this coefficient which is 1 like this. Then x uyu ari reduce by 1, saka anenge to the 0. Then y ari increase anenge to the 2. Saka what we want to achieve is tokuda kuti x which is the first term atange ari maxed out. Otanga kudi kudona kusvikira ane 0, to the power 0 like this. Tobva tazoda kuti y yambotanga ari to the 0, otanga kuincrease kusvikira ava squared. And squared tikuiwana kupi ndeishi. Ndo zviri kuitika panapa. Muri kuunderstandere mawaves acho. So manje zvaitika nemutoo uyu zvenge zvakungodai so. This is equal to 1. Atoziva kuti atinyori 1 as a coefficient. We know that, and saka 1 atinyori, tonyora x squared. Tinoziva kuti y to the power 0 ndi 1, saka atinyori totati plus 2xy like this, plus x to the 0 atinyori ndi 1 y squared. Saka this is the general statement. Murupaona, this is what is called the general statement. Inoi i general statement. Saka yandiri kukuratidzai iyi method yekutenderera, but inoshandiswa kana tichidzidzisa zvinhu zvacho. Otherwise I'm going to show you a second method iri direct. Maona kudai so manje, tengeta kudai. Munogona yenyu kuturikadzanisa 2 plus x squared na x plus y squared. Then inoi iri equal to x squared plus 2xy plus y squared. Then inoi manje zvataita kuisa imwe pamusoro imwe pazasi kuti muone kuti x anenge ari 2, y anenge ari x, then aya ma2 aya akangofanana like this. Kureva kuti panapa inenge iri equal to kwanzi x squared, saka 2 squared plus 2 times x ndeyani ndi 2, y ndeyani ndi x, andika mati plus ko y apo ndiani ndi x squared. So this is equal to 2 squared ndi 4 plus 2 times 2 ndi 4x plus x squared. Mukacherechedza muchaona kufanana kwazvakaita na 4 plus 4x plus x squared. It is the same answer, the same thing. Zvatawana. Mapaona. Saka munogona kutanga mambonyora a general statement yaminge mchishandisa x plus y to the power 2. Mapedza kunyora a general statement yatati munotora ma coefficients ku Pascal's triangle mobva mati first term inotanga iri maxed out yotanga kudonha kudzokera ku 0, second term inotanga iri 0 yotanga kuwedzera kuenda ku the maximum order, which in our case was 2. Then madaro mozongokombea kuti x ndiani y ndiani handika, then mongo replace, you are going to get your answer. The second method you can do, which is a more practical method, is this. Tiri kuda kuweka 2 plus x squared. Saka chatotanga kuita tinoisa Pascal's triangle yedu pa side 1 1 1 1 2 1. Totoona kuti 2 iyi ndiyo 2 inoi, saka totogumira panapa. Saka ma coefficients atoda kudila nawo ndi 1 2 1 like this. Handitika. Saka panapa manje izi zvinowanzo kushanda kana mazvijaira. Munenge makungoti 2 plus x squared is equal to, handika, totanga tatora coefficient which is 1, and but 1 iri kumultiply chi, then iri kumultiply x, but x panapa ndi 2 anofanira kunge ari maxed out, saka 2 chi squared, then y uyu anova second term anofanira kuva 0, saka x to the power 0 like this. Muri kuona kuti that one can actually be more complicated pane kuti mutange mawana a general statement mozongokombea zvinhu muchi substitution yamakaita yai. Saka madai somema kuti plus coefficient 2 times first term 2 iyo yanga imbori squared, so that ya to the power 1 times second term yanga imbori to the 0 inge ya to the 1 like this, plus coefficient 1 times first term yanga imbori to the power 1, so that ya to the power 0 times x yanga imbori second term yanga imbori to the power 1, so that yachi squared like this. So this is going to be equal to 1 times 2 squared into 4, but 4 times x to the power 0 and rambari 4, plus 2 times 2 into 4, 4 times x into 4x, plus 1 times 2 to the 0, so often 1 times 1 to 1 times x squared like this. Inongodzoka answer yedu sezvairi. So I encourage you to mutange mambonyora a general statement, then manyora a general statement kudaro mozongo substitute zvinhu. That's my advice to you. So let us just have a rundown of a few examples. Example number 2. Gatimboitai 2x plus 3 to the power 4. But before we go there, insanda tokanganwa, you have to know kuti to apply the Pascal's triangle, n should always be a positive whole number. Saka n inofanirwa kuva a positive whole number, just like for the binomial theorem. Saka condition e inofanirwa kumitiwa, because panapa we are talking about x plus y to the power 1, x plus y squared tichidzika. Mapowers edu they are always positive and they are also whole numbers. So that's important. The power, the exponent, the order should be a positive whole number, just the same as in the binomial theorem. Okay. Saka toda kusolve this one. Tinoita say, to expand that, tinotanga taisa pasi the Pascal's triangle up to the point where we have 4. Saka tinoti 1, and let me use white. Tinoti 1 panapan tuatatu 1 1 1 2 1 1 3 3 1 1 4 6 4 1. Tasvika pana 4 panapa. Kureva kuti ma coefficients atoda kushandisa nde I. Handiti. Taita determine ma coefficients atiri kuda kushandisa tenge takungoda iso. Let us put down a general statement. Saka general statement yedu x plus y to the power 4 inenge iri equal to, totanga the first coefficient anova 1, then saka tinogona kusamunyora tinenge tati jairirei. Saka teta kuti chi, teta kungoti x to the power 4 y to the power 0 togona kusainyora futi toti plus panapa chi pana 4 yova chi x cubed y plus 6. Let me push this kuside ukutra kuti zvinhu zvangu sakanganisika. Saka inenge plus 6 x squared y squared plus 4 and x y cubed plus y to the power 4. Saka na majaira muchaona kuti munenge makugona kuzvinyora musina kuisa ma1 nema x to the power 0 kana y to the power 0. Asi kana muchiri pa learning curve, I would encourage kuti mudaro. Okay, this is the general statement. Saka panapa tinogona mogona kubva mazonyora kuti chi x wenyu ndi 2x. Mapaona andika kana kuti musa confuse that x what ngatinyore takadai so. I think this is wiser because tinowanza kudila nema x ka. Saka manje kuti ndizotaura kuti x is equals to 2x azvizo make sense manje zvino confuse. Saka toda kuita just a slight improvement. For our general statement toda kushandisa a na b, so it's a plus b to the power 4 and saka inenge equal to a to the power 4 plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the 4 like this. Saka manje zvakumeka sense tikati a iri equal to 2x because a iri kurepresent a first term, b iri equal to 3 because b iri kurepresent a second term. Ndo zvatirongoda kureva kuti kana takuti 2x plus 3 to the power 4 is equal to, teta kuti a ndiani ndi 2x to the power 4 plus 4 2x to the power 3, b ndiani ndi 3 like this plus 6 2x squared 3 squared plus 4 2x 3 cubed plus then b 3 to the 4 like this. Saka mukasolva iyo zvatoita kungosolva iyo chete zvatoita. So let us solve it. This is equal to, what is 2x to the power 4? So remember number inoresewa to the 4, variable unknown to the 4. Saka 2 times 2 ndi 4, 4 times 2 ndi 8, 8 times 2 ndi 16. So apa inenge iri 16x to the power 4. What is 4 times 3? Saka panapa tinogona kutoshandisa edu calculator edu. Saka nchatanga nda verify 2 to the 4 because I am afraid of arithmetic errors. Yes, it's 16. Saka apo kuti 4 times 3 4 8 12. Saka it's 12 times 2 cubed. 2 cubed inobuda iri 96. So apo inenge iri plus 96x to the power 3. Tova tati plus, what is 6 times 9? 45 54. Saka toda multiply 54 times 4, 216x squared plus then what is 3 to the 3? 3 to the 3, it's 27. So that's 27 times 4 times 2, 216. So it's 216x plus, what is 3 to the 4? 81 like this. Can we solve it any further? No, we can't. Satatoda iso ninge yatobuda. Try to do it in a traditional way. Yekuda iso yekuti this is equal to 2x plus 3, 2x plus 3, 2x plus 3, 2x plus 3. Mono kuti munoita gore rese pane kungo apply either binomial theorem, universal expansion theorem kana kuti atadzidza izvezvi Pascal's triangle. So ndo zvatinongoita. The answer we get 16 x to the 4 plus 96 x cubed plus 216 x squared plus 216x plus 81. So that is how it's done, amadzangu. I really hope kuti with this one example it's sufficient. I hope you understood kuti how do we find or how do we apply Pascal's triangle. If you have any queries, problems, questions, critiques, please use the comments section. If you want to communicate directly to us, be it you want extra lessons, tutoring sessions, you can communicate with us on the numbers which are about to appear on your screen, preferably using WhatsApp. Otherwise, thank you and take care. The last thing is, mukaenda kuma questions atakaita for binomial theorem, munogona kushandisa ma questions yawo muchizama kumaita muchishandisa Pascal's triangle. That's further practice for you. Thank you.